Good afternoon and welcome to this Pittini Steel Head webinar, part of a series of speech organized by Pittini Group about steel technology and steel product application. Today we will talk about technological innovations in the Verona wire rod mill with Alessandro Stefanescu, the manager of export wire rod sales, and with Gianbruno Verona, which is part of quality department and is our metallurgist. Before we start, I want to remember you that we have a live chat, and if you have any question of topic about the topic of today, you can post it there. I will transfer it to the our relator. But let's start now with Alessandro. Good morning, Alessandro.
Hello, Flavio. Welcome, everybody.
We'll start with a question that we are talking about this new wire rod mill in Verona that we made. But before talking about this specific wire rod mill, can you just give us a little overview of the market share of Pittini in the wire rod market?
Thank you. Yeah, so first of all, I will give you an overview concerning the Pittini Group production. So Pittini Group is a quality carbon steel producer with a production capacity of more than 3 million tons of steel per year. This production is realized in 18 different manufacturing plants. Total turnover of the company is of about 1.5 billion euro. Pittini Group is an export-oriented company. Each year it serves more than 60 countries, and the current number of employees is about 1,800. For what concerns wire rod, the company is producing every year 2 million tons of wire rod for building and industrial application from a total production of 3 million tons of steel. We have two wire rod mills, one located in Osopo and one in Verona. Both locations are in the north of Italy. The Osopo mill produces more than 1.2 million tons of wire rod per year and is mainly focused in the production of low carbon wire rod. For what concerns Verona plant, the mill produces more than 700,000 tons of wire rod per year and is specialized in the production of medium and high carbon wire rod. Both wire rod rolling mills are designed for production of smooth and ribbed rods. The wire rod range of diameters goes from the standard 5.5 millimeter up to 21.5 millimeter. We produce high quality wire rod from low carbon grades up to medium and high carbon. As mentioned earlier, the Verona plant is specialized in the medium and high carbon steel and produces up to C82 carbon content wire rod. The standard packaging of the coils produced within the Pittini Group is a compact coil of 2.5 ton each.
Thank you with this overview. And why the decision to make a brand new wire rod mill in Verona specifically?
Yeah, well, Pittini Group is a well-known brand in the low carbon wire rod. The target of the new Verona rolling mill is to make an upgrade for what concerns wire rod offer. Not only a general improvement of low carbon drawing quality, but introduction of medium and high carbon grades as well, which basically allow us to open new markets for the company, different and additional to existing ones.
Okay, thank you very much, Alessandro. Now I want to leave the word to Gianbruno. Welcome, Gianbruno.
Welcome, testing. Good afternoon, everybody.
Yeah, an ambitious goal, I see. But to make this new plant, which aspects have been taken into consideration? Can you explain us more?
Yes, Flavio, thank you. Well, let me start by introducing what was our very initial target, our mission, let's say, that was not only to buy a state-of-the-art wire rod rolling mill, as Alexander said, for low, medium, and high carbon steel. But our idea was to cooperate from the very beginning with a supplier of rolling mill, of equipment, in order to get specific advantages, all focused on improvement of wire rod quality. This starting from the general layout, that means for us constant quality through the roller stock, passing through the application of thermomechanical rolling, and get to a new technology of cooling that is applicable thanks also to the work of our cooling conveyor. But I will say more about this later. All these features were linked, of course, by the installation all along the line of the best available technologies nowadays on the market. Just to make a point, the main idea here was to bring in this plant all the Pittini know-how in wire rod production, joined with the engineering knowledge of the rolling mill supplier.
Okay, so you talk about the layout and many other points, but let's start with this.
Yes, well, let's take a look at the rolling mill here. We need to highlight that one of the main benefits related with the construction of a brand new rolling mill is that we have the possibility and the opportunity to think and to place each equipment in the right place. So this without compromises. That means that the distances between each specific component was optimized and for the rolling process in general. Starting from the left side of the picture, we have the reheating furnace for the billet, but I will say a little bit more of this later. After that, we have the 4-stand high-speed roughing mill that was specifically designed in order to have the optimal deformation speed and reduction of area needed for squeeze the material and seal all the micro voids and micro defects present inside the original billet. Of course, just to digress for a moment, we need to remember that the billet is a custom product. So this means that it brings with inside the billet there are all the metallurgical features of a cast product, and we need to take care of this since the beginning of the rolling process. Okay, but let's get back to the layout. After the high-speed roughing mill, we can see that the rolling mill split into two different strands. Why is that? Because in this way, the rolling mill is able to guarantee the desired productivity, avoiding any issues related with the loss of quality of the product that can be related, that can be linked to different rolling stocks. This mainly related to different with the fact that we don't need to change the rolling speed during production. And then I would like to draw your attention on the last point of the but that is related to the orange arrows that remember us the position of the 5 water boxes or cooling unit that we have all along the strand. This equipment, it's the one of the key equipment useful for thermomechanical rolling process. That, of course, is finalized on the final cooling conveyor that is on the right here in the picture, just below the finishing area of the coil. And that's are just some example of what concerning the layout.
Okay, thank you very much. And you talk about a lot of technologies there. Which are the best technologies that you use on this mill?
Yes, concerning the best available technologies, we can underline two main aspects. The first is related to the equipment, and the second is related with the automation features of the mill. In relation with the equipment, earlier I mentioned the reheating furnace for the billet. That is a walking beam type furnace with two-side heating and selective temperature management for 9 zone. That's for uniform heating of the billets and for optimize the billet temperature and get a smooth and uniform rolling process. Passing through the selection of a no twist rolling for intermediate mill that allow us to avoid any quality issue that can be connected with the twisting of the material during rolling. And these are mainly related with, for example, superficial defects on the wire rod. And then the fourth step, sizing block, that is the final step of the rolling. That's for that guarantee a best sizing process. For what concerning other example about the equipment on the line, we have other two things that we can just to give you some other example. The first is connected with a high-speed shear that is able to crop the head and the tail of the product. So with this equipment, we are able to guarantee best homogeneity along the coil and defect-free tips of the coil. And after that, we need to mention all the equipment that is main responsible for the packaging of the coil, like laying head with wobbling system, several steps on the cooling conveyor, and the final rotating pit with easy down that can help us to get the best packaging for the general coil. Well, as earlier I mentioned also the second point that was related to the automation. About that, we can say that our rolling mill has been designed according to Industry 4.0 concept and is featured with the cutting-edge technology of steel rolling. For that, the plant was designed in order to control the entire production process. Basically, you can consider that we have 50,000 pieces of information through the network and constant monitoring and control of the section of the product all along the line. This with dedicated devices that are called high section, high gauge, high profile, but in general, the last of this can give already a prediction of the final wire rod shape and diameter, and can make very smooth and precise the final step of the rolling process that, as earlier mentioned, is the sizing step.
Okay, great. So a lot of technologies, but I think the real core of the plant is the thermomechanical rolling. So what we can say about the technology used by Pittini on this mill?
Well, okay, we need to start. We need to say that in modern rolling, a key role, of course, in obtaining quality rolled product is played by all the heat treatment along the whole process, joined together with the final cooling in the cooling conveyor. But how does it work? Basically, the temperature control along the rolling line guaranteed by each water box allow to apply the rolling deformation at the desired temperature. As a result of this, it is possible to apply the thermomechanically controlled process. For this, it might be useful to give a little background here. So for that, we need to consider the microstructure of the steel, and to consider that the microstructure is formed by austenitic grains. Well, the thermomechanically controlled process allow us to get a smaller austenitic grain size during rolling and keep it till to the cooling conveyor. This feature is one of the main aspects behind the final product properties enhancement and related to thermomechanical control process.
Talk a little bit about air patenting before. I see that in this mill you have a new concept of air patenting. Can you explain us more?
Yes, okay, some particular features of the cooling conveyor and air patenting treatment are here represented. On the right side up, for example, we can see another key point of the whole process, that is the specific new design of the cooling conveyor nozzles. Practically, below the roller table, we have this inside the cooling conveyor. Below the roller table, we have installed this specific new model of nozzles that can guarantee the best homogeneity of the forced air treatment, and this spacing from the lower flow rate, that means lower cooling rate for the product, to the highest cooling rate, and this highest cooling rate are the highest that can be applied nowadays in an air patenting process. And for what concerning homogeneity, we can say that we consider both the uniform properties all along the ring of the coil and from the head and the tail of the coil. Finally, with the aim of the hoods, we can also control the final properties of the product, and also where needed, optimize the scale quality and quality of the wire rod.
Okay, so you are a man of quality department. Can you talk us more about control during the production and on the final product?
Yes, okay, starting from process control, here is an example of what happens during final air patenting of 13 millimeters diameter of high carbon wire rod. This is a very interesting survey activity of what really happens on the cooling conveyor. Indeed, here is represented a real profile of temperature during the air patenting, final air patenting phase. And in this case, it's possible to see the position of the phase transformation from austenite to perlite, represented here by the position is represented here by the orange arrow. And we can also see that the transformation is well inside the area covered by the air fans that extend more than 50 meters. And is also clearly demonstrated here for us that until now the maximum cooling capability of the wall conveyor is far away to be reached. And okay, I would like to finish by saying something about product control, and here is possible to see an example of two main aspects related to microstructural features concerning perlitic high carbon steel. In general, we consider two main aspects of microstructure, both on micro scale with the optical microscope and on nano scale with scanning electron microscope. For example, on high carbon perlitic steel, particular attention must be paid to microstructural features like decarburization of the surface, superficial defects, and go deeper into the microstructure with the measure of interlamellar spacing of perlite and so on. These I can say are just some example of the needed laboratory control that we perform in our laboratory.
Okay, thank you very much, Gianbruno, for your intervention. And I remind everyone that Gianbruno is here later at the end for any of your questions about the mill. And now I will leave the word again to Alexandru, just to ask him which is the benefits of all these technologies on the wire rod, the quality of the wire rod.
Yes, Fabio, thanks. Well, there are several improvements on the wire rod produced in the new Verona rolling mill, thanks to the thermomechanical and the air patenting process. For the users' point of view, we are mainly talking about mechanical and geometrical improvement. Among others, let's say the most important are uniform mechanical and metallurgical properties in the same coil and in the same heat. This is achieved, again, among others, by the core heating of the billet in the reheating furnace, and this is guaranteed by the working beam technology. The thermomechanical rolling and air patenting are both playing a key role in achieving this result. In order to have uniform characteristics, we have to control the mechanical properties during the whole process. Not only the tensile strength, but also elongation properties. These are very important, for instance, in the production of PC strength and springs. Ovality control and size tolerances have also a special focus. I would like to highlight the twin module block device installed in the sizing mill for benefits in the final shape and tolerances. There are other important improvements in our wire rod, which are connected mainly to surface, coiling, and coil weight. A surface has to be defect-free, and this is achieved again by the sizing mill that I have just mentioned, and by the 3 blocks for a total of 18 stands for each of the 2 lines. The coiling, for what concerns coiling, in order to have not free and effective free coil, this is possible due to the laying heads and the conveyor wobbling for an optimal distribution of the material in the rotating conical pit. The coil weight, as mentioned earlier, is 2.5 ton, and it is a compact coil. For the coiling, we are using a rotating performing tube with the easy down unit. For what concerns compacting, a vertical compact is needed and is there. These are some of the improvements that have been already done, but some others are on the way. Another very important improvement for the user of our wire rod is not related only to the rolling mill itself, but to the whole production process that starts in the melting shop. So we are starting now to implement an integrated tracking system from single billet to single coil of wire rod produced. Basically, starting from the code of the coil, we can track all the history in terms of mechanical and chemical properties. This is very important for us in order to improve our quality standards, but this is very important for the final customer as well, in order to have and give better services.
Okay, and for our customers, which advantages they have in production and in their product too?
Yeah, well, for what concerns the production, so the processes, there are several that I'm going now to announce. Let's say we can say that we can split the advantages for the final application in two main categories: the process benefits and the benefits that are for the final product. The main target as a process benefit for the users is the increase of efficiency. Efficiency is a result of many factors. Among others, for instance, an easier descaling of the wire rod, both for mechanical descaling and chemical pickling. This is important in the process and is observed also in the lower consumption of dies. In terms of efficiency, a high drawing speed is also appreciated. A reduction of downtimes is observed thanks to less breaks in drawing process, reduction of the weld's head tail, and a fast uncoiling. Also, the handling and stocking of wire rod is optimized due to the 2.5 ton compact coil. For what concerns the final product, the advantages are mainly connected to the surface that should be bright, free of defects and smooth, of course. But mechanical characteristics are also very important, that must be constant, as the modern numerical control machines are very sensitive. And generally speaking, a better workability of the finished product is there.
Okay, thank you very much, Alessandro, also for your intervention. If there is no question, I'll wait just a few seconds for someone who's writing a few questions. I will leave you for the next webinar that we have in Italian this time about our mesh maplet and the system to use it. So thanks to you, and thanks to Gianbruno for your participation, and keep in touch.
Thank you.
Thank you. Goodbye.
Bye-bye.